What if the molecule is already drawn as a structural formula like this? How do we determine the hybridization then? Do we still need to use the steric number formula every single time? The answer is you certainly can, but there's an even faster method. It's called the sigma bond plus lone pair shortcut. Once you understand this technique, you'll be able to determine the hybridization of most molecules in just a few seconds. So first, let's understand how to recognize the different types of bonds. In a structural formula, each line represents a chemical bond between two atoms. One line represents a single bond, two lines represent a double bond, and three lines represent a triple bond. Now here's the most important rule. A single bond always contains one sigma bond. A double bond contains one sigma bond and one pi bond. The first bond is always the sigma bond, and the second bond is the pi bond. A triple bond contains one sigma bond and two pi bonds. Again, the first bond is always the sigma bond, while the second and third bonds are pi bonds. Now, here's the shortcut. When determining hybridization, we count only sigma bonds and lone pairs. We never count pi bonds. Why? Because sigma bonds and lone pairs determine the steric number, and the steric number determines the hybridization. Now let's see how this works. First, methane, CH4. Focus only on the central carbon atom. Carbon forms 4 single bonds with 4 hydrogen atoms. Each single bond contains one sigma bond. So carbon has 4 sigma bonds and 0 lone pairs. 4 plus 0 equals 4. A steric number of 4 means the hybridization is sp3, its geometry is tetrahedral, with a bond angle of approximately 109.5 degrees. Now let's move to the next molecule. Ethene, C2H4. We'll determine the hybridization of one carbon atom. Since both carbon atoms are identical, the answer will be the same for either one. That carbon forms 2 single bonds with hydrogen and 1 double bond with the other carbon. Remember, a double bond still contains only 1 sigma bond. The other bond is a pi bond, and we do not count pi bonds, so carbon has 3 sigma bonds and 0 lone pairs. 3 plus 0 equals 3. A steric number of 3 means the hybridization is sp2. Its geometry is trigonal planar, with a bond angle of 120 degrees. Now let's look at our final molecule. Ethene, C2H2. Again, focus on just one carbon atom. That carbon forms 1 single bond with hydrogen and 1 triple bond with the other carbon. Remember, a triple bond contains 1 sigma bond and 2 pi bonds. We count only the sigma bond. So carbon has 2 sigma bonds and 0 lone pairs. 2 plus 0 equals 2. A steric number of 2 means the hybridization is sp. Its geometry is linear, with a bond angle of 180 degrees. Did you notice the pattern? Molecules with only single bonds are usually sp3 hybridized. Molecules containing a double bond are usually sp2 hybridized, and molecules containing a triple bond are usually sp hybridized. Just remember one important point. Don't look at the entire molecule. Always determine the hybridization of the specific atom you're interested in. Now you've learned 2 powerful methods, the steric number method and the sigma bond plus lone pair shortcut. With these 2 techniques, you can determine the hybridization of almost any molecule with confidence. Thank you so much for watching, and I'll see you in the next lesson.